Okay, the purpose of this video is to look at when can you use the central limit theorem. So in a sense, the central limit theorem is giving us permission to let the mean of x bar be mu and the standard deviation of x bar be the standard deviation divided by the square root of n. This is true if the original population is normal or if the sampling size is large, and large is defined to be greater than or equal to 30. So these are our guidelines. So in example 1, we have the braking distances of an SUV. They're normally distributed with a mean of 154 and a standard deviation of 5. We have a random sample of 6, which is very small, but because the population is normally distributed, then the mean of the means is still 154, and the standard deviation of the means would be 5 divided by the square root of 6. So yes, the central limit theorem can be applied for the first example. For our second example, the mean of salaries for people at San Jacinto College is $54,000, and I made this up. I'm just feeling like living on the edge today. And it has a standard deviation of 9 grand. We do a random sample of 45 professors. So can you apply the central limit theorem here? Well, it doesn't say anything about your population being normal, but since n is 45, that's large enough by definitions in the stats world so that we can say that the mean of the sample means would still be the 54,000. And the standard deviation gets adjusted by the size that you sample. So we'll do 9,000 divided by the square root of 45. Okay, so how does that affect working your word problems? And so I asked the question below, what's the probability that a randomly selected professor would make at least 60,000? So that question is asking what's the probability that X would be at least 60,000. All right. Versus in part B, I ask what's the probability that 45 selected had an average salary of at least 60,000. So it's not a variable of X this time, it's a variable of X bar. How does that change your calculations? Well, you're still going to find z-scores for both of those. So for part A, to find the z-score, you would take the 60,000 minus the, what did I say we make? Because I don't believe it, the 54,000, and you would just divide by 9,000, which was the standard deviation. And that would get you your z-score, and then you could look that up on your table. For part B, though, to do the standard deviation, you have a little bit of an adjustment because of the sample size. So you do the 60,000 minus the 54,000. We're going to divide by 9,000, but that 9,000 is getting divided by the square root of 45. Now, for those of you that are not calculator savvy, be super careful. You really need parentheses around your entire numerator and your entire denominator to get the numbers to come out correctly. Okay, so then that would give us our z-score. So let's calculate both of those. Okay, so we get a z-score of 0.67 and we get a z-score of 4.47. So for both of these, because it's greater than, you need to do 1 minus whatever you would find on your table. For this particular one, though, 4.47 is off the table. So we're talking about being bigger than this. And if you looked at your picture, a z-score of 4 something would be way out here. What area would even be to the right of it? Well, pretty much none. So the probability of finding 45 randomly selected professors making an average of $60,000 is pretty much nothing, which is kind of sad. And sadly, I don't think I'm off too far by my numbers. Okay, but for this guy, the 0.67, we would go to our table, we would look up a z-score of 0.67, and then we would subtract it from 1. Okay, so what did you get? I'm still looking at mine. Just kidding. So you should get something roughly 0.7486, I think. And if we subtract that from 1, then we actually get the average we want because it was to the right. So you had a 25% chance of catching one person that would make 60 grand if the average of the population was 54 grand. But then when I wanted to capture 45 people that made an average of $60,000, that was pretty much impossible. I hope that helps in 5.4. Email any more questions that you have. This is the last section that we are going to cover in Chapter 5. So you have plenty of time to master the material in Chapter 5 because we don't have a test for a couple more weeks. So woohoo us. Have a great day.